All right, so section 2.6, we're still working with exponential and logarithmic functions. However, in the previous two sections, 2.2 and 2.3, we were using base E, okay, that constant that's approximately equal to 2.7. Well, in this section, we're going to look at logarithms that have different bases. So the rule that we're taking, so here's our, not just logarithms, but exponentials also. Here is our function, y equals a to the x power. So this is an exponential function. A is a constant and x is the variable, and that's what qualifies it as an exponential function. And the rule for finding the derivative of that is that the derivative is the same function, just like with e to the x, but now you have to take the natural log, multiply it by the natural log of a. So when our constant was an e, the natural log of e is just 1, so you don't have to multiply by the natural log of e because it's 1. But since a is not e, you have to multiply by the natural log of a. Okay, so that's the rule for that exponential function. And then for the logarithmic function, which has base a of x, the derivative, just like with the natural log, you take the reciprocal, so you're going to have 1 over x, but then you've got to multiply by the natural log of a. Since this is not an e, ln of a is not equal to 1. Okay, so those are your rules for general exponential and general logarithmic functions. These are your new rules, okay? So really, we're really only adding 2 new rules. It's just that when a is equal to the constant e, since ln of e is 1, you don't have to write ln, you just, it's e to the x and it's 1 over x, okay? So really, these are the more general rules. I just wanted to introduce the easier one first, and now I'm going to show you how we do examples here with these 2 rules. So let's suppose we have our function y equal 3a to the x. Oh, let me put in a constant there, 2, let's say. That's kind of weird looking, 2. But so y equals 2 to the x squared, okay? Well, the derivative, since we have a constant multiple, we just keep that constant. And remember, the derivative of an exponential function is just the same thing, except since we have 2, so we're just going to copy what we see here, 3 to x squared. But since this is not equal to e, we have to multiply that by ln of 2. And then by the chain rule, we have to multiply it by 2x. Okay? So it's a little bit, one extra step, but really it's the same rules that you're applying. Just one extra step, you got to multiply by that constant there. So just to simplify this, the way I would write this is I would write 3 ln 2, that's my constant, and then I got the 3 ln 2, then I would put the 2x in there, so here's my constant. Oh, actually, I would take 2 times, well, I'll just go and write it out like this. And then I'll fix that. So here we go. 3 times 2 is 6x ln 2 times 2x squared. I guess that's how I would finish it off. Okay, they're really lenient with how you write your derivatives, as I've mentioned before. And if it's a multiple choice situation, then you should be able to identify which the correct derivative is. Okay? Any questions on that one? Okay. Okay, I look at this example and I see that I have 2 to the square root of x. I'm thinking right off the bat, what I should be thinking is that's an exponential function. And how do I know? Because the 2 is constant, that's the base is constant, and the exponent is a variable, okay? So right away, when I see an exponential function, my thought is copy what you see for the derivative. So that's my first step. I'm going to copy what I see there, okay? And now I'm going to say to myself, this constant here, this 2, is not equal to e. Therefore, I have to multiply by the natural log of 2. And then I'm going to say to myself, the exponent is not just plain old x, so I apply the chain rule, and I have to multiply by the derivative of the square root of x. And just to refresh your memory, what is the derivative of the square root of x? Well, you think of this as the derivative of x to the 1/2, and applying the power rule, that is 1/2 x. Subtracting 1 from 1/2 gives me minus 1/2. And so that's 1/2 square root of x. Okay, this is the derivative of this exponent. So finally, that's an aside, I have that the derivative is equal to 2 square root of x ln 2 times 1/2 square root of x. Okay, and to simplify that, I would probably write it as my constant out front, that's the natural log of 2. Then I've got 2 square root of x divided by 2 times the square root of x. Okay, any questions on that one? So really, when you're doing these exponential functions with a different base other than e, you're going to copy what you see, just like you do with base e, but since this is not an e, you multiply by the natural log of the constant base, and then of course applying the chain rule, you have to take the derivative of the exponent. So there you have it, okay? And then it's just a matter of simplifying it. Any questions on that one? How are we on time here? I don't have my cell phone. Let me see. Hold on. 11:44. Oh, good. We still got some time. All righty. Okay, so let's do a couple examples using the log function with base other than e. Okay. So our function is log base 3 of 5x cubed minus 3x squared plus 2. Okay, so right there you can see we have a composition. We have a polynomial inside a log. And so remember, with log functions, you write down, your first step is write down the reciprocal. So when you take the derivative, you take 1 over this whole thing. Then you say to yourself, my base is 3. Since that's not equal to e, In other words, I don't have the natural log here. I have log of base 3. Then I have to multiply by the constant ln of 3. And then finally, because my input is not plain old x, I have to take the derivative of this inside function here. And so I need to multiply then by 3 times 5 is 15x squared, subtracting 1 from 3, minus 2 times 3, that's 6x. And the derivative of this constant here is 0. Okay, so this is my final derivative here. Oh, I made a mistake. Oh gosh. This is 1 over ln 3. Just like you're taking 1 over the, you multiply by ln 3 when it's the exponential function, not the logarithmic function. I kind of got that backwards. Let's go back to our rules. Sorry, I just was in the mode of doing exponential functions and switching to logs. Let's see, where did I introduce that? I'm looking for my page here. I wonder if it's under here. I hope I did it right. Yeah, right here. So here's our rule. We have log base, in the other example was a 3, but here's a constant a. You take the reciprocal of 1 over, what's your input, x, so 1 over x, but then you multiply by ln a in the denominator, right? And here I started to multiply by ln 3, but not in the denominator. So it's also got to be in the denominator, just like your input here. Your ln 3 has to be in the denominator, okay? So I just want to clarify that. I almost made that mistake, but I caught myself, thankfully. Okay, so I don't know the way I would write this. I suppose if I were to simplify this, I would just write it as 15x squared minus 6x. There's the numerator. And then the 5x cubed minus 3x squared plus 2. And then, of course, you just multiply it by ln 3 in the denominator there. That's fine. Okay? Any questions on that? On that one? All right. Let's do one with the product rule so we can practice that. It's always good to practice our rules. So let's try one with the product rule. All right, the product rule, let's see. Let's suppose we have y equals x squared times log base 5 of x. Okay, so we have a power function and a log function. And the product rule says we take the first times the derivative of the second. So taking the derivative of this, whenever you take the derivative of a log function, you take 1 over x, so we just have plain old x in here. But because this base is not e, we multiply by ln 5 in the denominator there, like that, okay? So we have the first function times the derivative of the second, plus the second function times the derivative of the first. Okay, that's the product rule. Now, to simplify this, I suppose I would just go x squared divided by x. That's going to cancel out an x there in the denominator. And so I have x in the numerator divided by ln 5. And then I'm adding to that 2x times, or I'll say 2x log 5x. Okay, so there's my derivative. So it's really just the same rules as when you have e to the x and the natural log of x. You just have that one constant that you've got to multiply by. So when you're doing an exponential function, you multiply the numerator by that constant, and when you're doing a log function, you multiply it in the denominator.